Okay, hello students. So I thought I'd show you a more specific example of what it is we're going to try to measure with the Arduino in the context of logging the waiting time between gamma ray emissions. So of course what I have down here on channel 1 is the typical output of the gamma ray amplifier. Remember, the amplitudes are sort of proportional to the gamma ray energy coming in, and that means the different amplitudes you see in here represent different energy of gamma rays that are detected by the detector. And of course the SCA is firing up here too when one of these amplitudes goes between its setting of its window with the lower level and upper level discriminator. So you can see the green pulses in the top there. So what I'll do now is let me just sort of look at a longer time span here, and I'll sort of compress it down, and I'll move the main event way over. So this is sort of a compressed version of the event we were just looking at, and there's its corresponding pulse from the SCA right there. And now if I sort of run it in single, you can sort of see what we're talking about. If I get, there we go, something like this is just perfect. Look at this. So what we've have happened here is the gamma ray arrived here and triggered the SCA, and then a bunch of time went by. In this case, it looks like about, I have the oscilloscope on 200 microseconds per division, so about 200, 400, about 500 microseconds goes by. And after the 500 microseconds goes by, we see another gamma ray appear. There's the event right there out of the amplifier, and there's the SCA triggering. Then you got to wait a little for the next one, the next one, the next one. So these are exactly the times we'd like to log. So what our logic is going to be in the Arduino software is wait for this rising edge here, and then just keep waiting and waiting and waiting. And this is going to represent another rising edge for another gamma ray. So this will be t is equal to 0. Time how long it takes, in this case, is going to be about 500 microseconds. And on this rising edge, start the timer over again. So set like t is equal to 0 again, and wait about this long. Looks like about 100 microseconds for this pulse, and there'll be another 100 microsecond one right there, and then it looks like there's going to be a longer wait for this one. So as you can see, that's sort of the logic we'll apply in our software here. We'll always use the first pulse to start the timer, and when the second pulse comes in, we'll sort of log that time or display that time and start the timer over again in anticipation for the very next pulse. So it's the time between all those individual pulses there is the one that we're going for. And this is a very nice example. You can clearly see it's not going to be uniform at all. There's some really long times, there's some short times, and some intermediate times, and on it goes like that. So the Arduino is just going to look really doodly for us here at timing the interval that we have to wait between all those little SCA pulses that you see going on in there. So it should be kind of interesting, but that's exactly what we'll be looking for in the waiting time between gamma ray emissions experiment, and hopefully we'll see something interesting in the pattern of those times that we get.